Greetings mga ka-spacers natin out there. Good day to everybody. And welcome to this Astrobiology online lecture series. Now in today's video, we will be answering the question, what are the planets in our solar system aside from our planet Earth that are capable of sustaining or supporting life? So we will be mentioning planets or even moons in our solar system that are possible candidates for the existence of life outside our planet Earth. So we will be mentioning planets such as the planet Mars, Europa, one of the moons of Jupiter, even Ganymede based on the latest discoveries made by the Juno space probe, Titan, one of the moons of Saturn, and even Enceladus, also one of the moons of Saturn. So mga ka-spacers natin out there, please like and share this video so that we could reach more people, especially the students out there, so that they will be inspired to love the sciences. And also mga ka-spacers, please subscribe to my YouTube channel, The Science Guy, Prof Jun Cajigal. Alright, so let us now proceed to our discussion for this video. What are the planets in our solar system aside from our planet Earth that are capable of supporting or sustaining life? So join me as we answer that question. Now, we know that life on Earth requires liquid water, energy, nutrients, and a habitable zone to survive. Now, what about life as we don't know it? Now, studies of life in extreme environments on Earth have led us to focus on some prime places to look for life. So we are now considering some members of the solar system that might support life. So we have the following, like Mars. Mars is a pretty good candidate for the existence of life outside planet Earth. Also, we have Europa, one of the Galilean moons of Jupiter. Then we have Titan, the largest moon of Saturn, and Enceladus, one of the moons of Saturn. Now, let us study the possibility of life on the red planet Mars. Now, Mars is probably the planet most likely to harbor life. Now, why? Now, there is abundant geological evidence from spacecraft explorations that Mars once had a thicker atmosphere and probably liquid water on its surface. Now, at present, there is no liquid water on the Martian surface. Water would simply evaporate due to the low Martian atmospheric pressure. But there is evidence to prove that liquid water may once have flowed in the past. Now, our astronomers have discovered geological structures that resemble canals or channels. So this is an evidence to prove that water may once flowed on the Martian surface. So these geological structures resembled canals, and these canals may have been carved by running water. So there are canals or channels on the Martian surface. And these channels or canals may have been carved by running water. So there is geological evidence to support the idea that water may have once flowed on the Martian surface. So the question is, where is now the water? Now, water may have been trapped in the polar ice caps. The polar ice caps of Mars contains mostly carbon dioxide ice or dry ice, but it may also contain water. Now, water is thought to have flowed across the surface of Mars billions of years ago, when its atmosphere was thicker and warmer, cutting gullies and channels that are still visible. But today, the low atmospheric pressure means that any surface water would boil away. So water survives frozen in polar ice caps and in subsurface ice deposits. Now, it was the Americans through NASA that spearheaded the exploration of Mars. And one of the early space probes that landed on the red planet was Viking. So the Viking probes of the mid-1970s carried experiments designed to detect microorganisms in the Martian soil at their respective landing sites. So there were two Viking space probes, Viking 1 and Viking 2. And the Viking probes, they are mobile laboratories designed to detect any microorganisms that might be present in the Martian soil. So this is Viking that soft landed on the planet Mars. And Viking has a retractable robotic arm that can scoop out Martian soil. The Martian soil is then delivered to the mobile laboratory. Now here is a panoramic view of the Martian surface taken by the Viking space probe. So you will notice through the pictures that the Martian terrain resembles that of a desert. Now, since the Martian temperature resembles that of Antarctica, we can say that the Martian terrain resembles that of a frozen desert. Okay, so isn't that fascinating about the Martian terrain? Now, here is a cutaway view of Viking, and this is the cutaway view of the biolab that was designed to detect the presence of any microorganisms in the Martian soil. So let us now study briefly what this biolab package in Viking does. Now, this is the so-called labeled release experiment. The labeled release experiment mixed small samples of Martian soil as scooped up by the robotic arm of Viking with drops of water containing a nutrient solution and some radioactive carbon. The instrument then sampled the atmosphere of its internal chamber, as you could see in the diagram. If it detected the radioactive carbon, the thinking went, then microorganisms in the soil must have metabolized the nutrients and emitted the carbon. The air around the control version, in contrast, heated up to temperatures, yet Viking saw no signs of life or of the other organic compounds needed to support life. So many scientists concluded that the results were too good to believe that the findings might be explained by reactive chemicals such as percolates in the Martian soil. So NASA had sent more probes on the red planet to continue the search for life. So here is a picture of the Viking lander's sampling arm that scooped up samples of Martian soil. The Martian soil was then brought to the biological instrument package on board Viking and automatically conducted several biology experiments that would detect any signs of life present in the Martian soil. But unfortunately, none were found. So NASA continued the search for life on the planet Mars. Now, some of the latest Mars information comes from the 5 active probes on or in orbit around Mars, including 3 orbiters and 3 rovers. So this includes the following. So we have Pathfinder, the 2001 Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter, the Sojourner rover, rover, the Opportunity rover, the Curiosity rover, and this coming Feb 18, 2021, we have the Perseverance rover that will land on the planet Mars. So we have here the Mars Pathfinder rover sojourner exploring the Martian surface. Then we have the Opportunity Mars rover. Then we have here the Mars Curiosity rover, and this rover is as big as a Volkswagen. And we have here the Mars 2020 Perseverance rover, and by the way, this coming Feb 18, 2021, the Perseverance rover will land on the red planet. The Perseverance rover is equipped with specialized equipment, and what is so fascinating about the Perseverance rover is that it has with it a helicopter called the Ingenuity helicopter. So isn't that fascinating indeed? Although Mars has the most Earth-like environment of any other planet in the solar system, the surface is too dry and too cold and too affected by solar ultraviolet radiation to meet the requirements for habitability. So our search for life on the red planet continues. NASA continues the search for possible life on the red planet. And that's the mission of the Perseverance rover. Now let's take a look at the possibility of life on Europa, one of the Galilean moons of Jupiter. Now the Voyager space probes have visited Europa, and the Voyager space probes have discovered that the surface of Europa is covered with a thick icy sheet. Now scientists think that Europa's icy sheet is about 10 to 15 miles thick, and scientists believe that beneath that icy sheet may be liquid water. So that icy sheet may be floating on an ocean at about 40 to 100 miles deep. So while Europa is only 1/4 the diameter of Earth, its ocean may contain twice as much water as all of the Earth's oceans combined. So that is Europa. Europa may contain a vast inner ocean. So underneath that thick icy sheet, Europa may contain a vast inner ocean that's thought to be in contact with its seafloor, potentially infusing the water with the energy and nutrients needed to support life. Okay, so that is Europa, one of the Galilean moons of Jupiter. And as discovered by the Voyager space probe, the surface of Europa is covered with this thick icy sheet made of water ice. And scientists believe that beneath that icy sheet may contain liquid water. So that's the story of Europa. So beneath that solid ice may be liquid water. So Europa is a pretty good candidate for the existence of life outside planet Earth. And what's exciting about Europa is that in 2013, the Hubble Space Telescope discovered water vapor venting from the surface of Europa. Now, this discovery that water vapor is ejected or venting on the surface of Europa is very significant. This would prove the idea that beneath the icy sheet of Europa is liquid water. And if there is liquid water, then probably microbial life may exist. So this discovery of water vapor venting from the surface of Europa will strengthen Europa's position as the top candidate for potential habitability of microbial life. Now, NASA is planning a mission to Europa. So NASA plans to send a robotic space probe. This robotic space probe will drill a hole through the the icy sheet of Europa. And once the space probe penetrated the thick icy sheet of Europa, it will send a robotic submarine to explore the inner oceans of Europa. So isn't that fascinating indeed? Now let's take a look at the possibility of life on Titan. Titan is the largest moon of Saturn. Now, Titan, being Saturn's largest moon, is a mysterious place. Titan is the only moon in the solar system that has a thick atmosphere. Titan's atmosphere is composed mostly of nitrogen, which is similar to the Earth's atmosphere. The Earth's atmosphere is composed mostly of nitrogen at about 70% and 21% is oxygen. So Titan's atmosphere is quite similar to our atmosphere here on Earth. And Titan's atmosphere also contains organic compounds aside from nitrogen. Now, Titan and Saturn has been visited by the Voyager space probes. So the Voyager space probes visited Saturn and some of its moons. And the Cassini-Huygens probe also visited Saturn. Now, the Huygens probe visited and landed on Titan. Okay, so Titan has been visited by the Huygens probe and made a soft landing on its surface. And like what I have mentioned, the atmosphere of Titan is composed mostly of nitrogen with traces of other organic compounds such as argon and methane. And compare that with our atmosphere, the Earth's atmosphere is also composed mostly of nitrogen with oxygen that is about 21% and other organic compounds such as argon. Now, the Huygens space probe have made significant discoveries on Titan. The Huygens space probe have discovered liquid on Titan. Not liquid water, but liquid methane. In fact, the Huygens space probe have discovered lakes of methane on the surface of Titan. Now, we know here on Earth that there are organisms called methanogens that can withstand very high concentrations of methane. So there is a possibility that these methane lakes may support similar organisms or methanogens. So that is very fascinating indeed. And in June of 2010, scientists analyzing data from the Cassini-Huygens space probe reported anomalies in the atmosphere near the surface which could be consistent with the presence of methane-producing organisms, but may alternately be due to non-living chemical or meteorological processes. So we still need to confirm such findings. And what's more exciting about the Huygens space probe is that the Huygens space probe have discovered a new molecule, and this molecule brings hope for the existence of life on Titan. This molecule found on Saturn's moon Titan could foster life, and this molecule is called acrylonitrile. Now, this molecule is a vital component for cell formation. So therefore, its presence is a strong indicator that life could well exist in one of Titan's many methane lakes and seas. Now, this molecule is so fascinating. Now, well, in fact, back here on Earth, acrylonitrile is also known as vinyl cyanide. And vinyl cyanide is useful in the manufacture of plastics. Now, under the harsh conditions of Saturn's largest moon, Titan, this molecule, acrylonitrile, is thought to be capable of forming stable, flexible structures which is similar to the cell membrane. So many scientists believe that the presence of acrylonitrile may foster life on Saturn's largest moon. Now, what about the possibility of life on Enceladus? Enceladus is also one of Saturn's moons. Now, the Cassini-Huygens probe have discovered water vapor venting on the surface of Enceladus, which is similar to Europa. And complex molecules have been discovered in the plumes of Saturn's moon Enceladus by the Cassini-Huygens probe. The data transmitted back to Earth by the Cassini-Saturn orbiter, which ended its service above the ring world on September 16, 2017. So isn't that fascinating that Enceladus also vents water vapor on its surface? And this is a strong indication that Enceladus may foster life. Okay, and the presence of liquid water venting on the surface of Enceladus and the discovery of complex organic molecules makes Enceladus a potentially habitable world for microbial life. So isn't that fascinating indeed?
This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds, and because of this, NASA is now planning a mission to Titan. But what did they find, and why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth's. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn and has a radius of about 1,600 miles. It takes the Titan 15 days and 22 hours to make a full orbit of Saturn and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander Huygens made a dramatic descent through the Moon's orange, smoggy atmosphere and landed on the surface of the Moon. The camera on Huygens shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy Moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the Moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in the hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenylidene, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together, creating a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed in the same point in the sky. The antennas pick up a signal from the target in the universe and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find. A weird molecule called cyclopropenylidene. C3H2 is a strange organic molecule that doesn't exist terrestrially on Earth and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the Milky Way, including the Taurus molecular cloud. This simple carbon-based molecule may be a precursor to more complex compounds, and it could form or even feed possible life on Titan, like organic molecules that formed life on Earth between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides benzene to have been found in Titan's atmosphere so far. Closed-loop molecules like it are important because they form the backbone rings for the nuclear bases of DNA and RNA, which is also a critical compound for life's functions. However, C3H2 is not known to be used in any modern-day biological reactions. NASA says the molecule could be an indicator for life, since something has to be generating an unstable molecule. If there is life on Titan, it would be incredibly different from water-based life forms we know of. NASA was so intrigued by this new discovery on Titan that it wants to study the Moon more and announced the Dragonfly mission in 2019, which is planned to launch in 2027. It'll take 9 years for it to reach Titan, arriving in 2036, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design and is much like a large quadcopter drone with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2035, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet. But with Dragonfly, scientists decided to take advantage of the Moon's low gravity with a flying vehicle. This will be the first time that NASA will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing the Earth for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from the Earth. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that'll keep cosmic rays and radiation from destroying it. And it will fly to many different locations to pick up surface materials for chemistry experiments. It'll also check out the planet to see if it's possible for humans to inhabit it one day. Since the building blocks of life, or the organic molecules on Titan, are expected to be similar to those on Earth before life arose, Dragonfly will help study how far pre-life chemistry has progressed to see how life evolved on our own planet. See, we have no idea how life really formed and began on our planet. All we know is that it involved organic molecules. Dragonfly will check out the moon's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to life. Now, the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us a lot more about Titan. It seems that we may soon find life on another planet or moon, and that'll be a very exciting time for science and humanity. Something recently happened that caught everyone's attention. NASA's Juno spacecraft is still out there wandering space, and for the first time since it was launched, it picked up an FM radio signal coming from Jupiter's moon, Ganymede. This is the same kind of signal that you would find here on Earth. In fact, we use this signal every day and know it as Wi-Fi. Did we just pick up an alien radio station broadcast from Ganymede? To figure that out, we need to know more about this icy alien world. Ganymede is the largest moon in the entire solar system. If it was orbiting the Sun, it would be a planet itself, being larger than Mercury. Although Ganymede doesn't have an atmosphere, it's the only known moon to have a powerful magnetosphere, which sometimes produce auroras that are affected by the moon's underground saltwater oceans. The rocking seen by the auroras gives researchers evidence that the underground oceans on Ganymede are possibly liquid and very salty, far saltier than the Earth's oceans. The FM signal that came from Ganymede originated from electrons in electromagnetic fields, a process causing the electrons to whirl and oscillate much slower than their spin rate. The Juno spacecraft detected the 5-second radio burst in late 2020, when the moon crossed a polar region of Jupiter where the gas giant's magnetic field interacts with Ganymede. So could there be life on Ganymede? Well, we know for sure the signal didn't originate from alien life. It's also very cold on Ganymede, with temperatures around minus 186 degrees Fahrenheit. However, during one of its flybys, the Galileo spacecraft detected a dense stream of atomic hydrogen escaping from the moon's very thin atmosphere. This means that there are large amounts of oxygen that's locked up or hovering over its icy surface. Atomic hydrogen is the lightest atom, and Ganymede has a weak gravitational field, so the hydrogen escapes and the atomic oxygen stays behind. Some researchers say that Ganymede could have as much oxygen on its icy surface as the Earth has in its atmosphere. So could Ganymede have everything for life to exist in its subsurface oceans? Some scientists think the pressure at the base of any ocean here would be so high that it would turn to ice. But a mission is needed to find out more. But this moon isn't the best candidate for life. In fact, there is another moon orbiting Jupiter that some scientists are calling the most habitable place inside our solar system. Europa is an icy white moon with brownish streaks on its surface and has an icy crust that could be from 2 to 20 miles thick. It's the smoothest surface of any other object in our solar system, and you wouldn't find any mountains or craters here. Underneath the icy surface would be a vast underground saltwater ocean, which could be twice the volume of those on Earth. Europa is very cold, with an average temperature of minus 260 degrees Fahrenheit, which keeps the icy crust as hard as granite. But could life still exist here? It's possible. At the dawn of the space age, it was thought that all life depended on the sun, and any object too far from a star would be a frozen ball of ice unable to support life. But finding thriving ecosystems at the bottom of Earth's oceans relying on hydrothermal vents changed all that. Now we know life is pretty tough, and it can survive completely isolated from the energy of a host star like our Sun. It's important to know this because Europa could harbour simple microbial life in liquid oceans underneath its icy crust, and this life could be surviving off the same kind of hydrothermal vents. So how do we know that Europa probably has liquid water needed for life to thrive? The Galileo spacecraft that flew over the moon in the 90s uncovered evidence of a vast, deep, dark, global subsurface ocean. Even though the moon should be a solid ball of ice, the water on Europa doesn't freeze completely because it's constantly churned by powerful tidal forces as the moon orbits around Jupiter. And at the same time, those tidal forces cause Europa's core to generate heat. Scientists are excited because this global ocean is thought to be in direct contact with surface ice and the moon's silicate mantle. This brings together everything needed for a habitable environment: liquid water, a source of energy, and a source of minerals and nutrients that life needs to flourish and survive. We know some bacteria or extremophiles like tardigrades can survive extreme environments, and just maybe, Europa's hidden ocean could have these kinds of life forms. Between 2014 and 2016, researchers got evidence that there might be liquid water on Europa. Hubble Space Telescopic images showed evidence of huge geysers of water vapor, some 62 miles high, erupting from the surface over Europa's south pole. Although some researchers aren't sure, we're going to find out soon enough. NASA wants to send a probe to Europa by 2025. The spacecraft is called the Europa Clipper, and it will explore whether this icy moon has conditions suitable for life or not. The $2 billion solar-powered probe will fly by Europa 40 to 45 times using a number of high-tech instruments to study the moon's icy shell and the ocean that's underneath the surface. Will it find life? Only time will tell. And what about the Jupiter moon Callisto? Is it possible life could exist there as well? Callisto is the second largest Jupiter moon and the third largest moon in the solar system. It's almost the exact same size as Mercury, but with a surface temperature of -218 degrees Fahrenheit. It was once thought to be a dead moon because of its ancient cratered surface. In fact, it has more craters on its surface than any other object in our solar system. If you have many craters on the surface of any astronomical object, it means that geological processes are probably dead. But Callisto also orbits too far away from Jupiter to be affected by the gas giant's magnetosphere and heavy gravity. However, Callisto may also have an underground ocean, and the satellite's icy crust might be acting like a cosmic blanket, insulating this underground ocean. It's not clear whether this ocean could hold life because the surface is so old. The only way to find out for sure what's happening on these icy moons is to send a probe. NASA and the European Space Agency are building the Jupiter Icy Moons Explorer, or JUICE, which is planned to launch sometime in 2022 and begin a 7.6-year cruise to Jupiter, arriving sometime in 2029. We've all heard about the James Webb Space Telescope and the amazing potential it will have to find habitable exoplanets. But the JUICE probe is going to be carrying the most powerful scientific payload ever flown to the outer solar system, which includes 10 state-of-the-art instruments, plus will perform an experiment using the spacecraft telecommunication system with ground-based instruments. During the first part of its 3.5-year mission, the JUICE probe will make 30 observation overflights of the 3 icy moons Callisto, Europa, and Ganymede, studying them in close detail by examining their gravity, magnetic interactions, and checking to see if liquid water really does exist under the surface of each one. It'll then investigate whether these oceans might hold the organic components necessary for life, or even life itself. There's another interesting moon that's been grabbing the attention of researchers lately, but it's not in Jupiter's orbit. However, we think it's worth mentioning if we're going to talk about finding life in the solar system. In 2019, NASA revealed the ocean on the Saturn moon Enceladus contains the building blocks for life. This vast water ocean is about 6 miles deep and lies under an icy crust that's 19 to 25 miles thick. Images of huge plumes of water vapor erupting through cracks at the south pole of Enceladus were captured by the Cassini spacecraft and indicate there must be an underground ocean. These plumes were analyzed by the folks at NASA and found to contain water vapor, ice, salts, methane, along with simple and complex organic molecules, the kind of stuff normally found in living systems. The newest study of Enceladus shows the moon is more geochemically complex than previously thought, and that carbon dioxide is being controlled by chemical reactions on the seafloor of an interior ocean, boosting the chances of the moon having some kind of life. On Earth, oxygen-breathing creatures consume energy in organic matter like glucose and oxygen to create carbon dioxide and water, and oxygen-breathing microbes can metabolize hydrogen to create methane. NASA's Cassini's Ion and Neutral Mass Spectrometer detected methane, carbon dioxide, ammonia, molecular nitrogen, and molecular hydrogen in the plumes. And molecular hydrogen would indicate there is free energy available in the oceans of Enceladus. Cracks in the ice where the plumes erupt have temperatures warm enough that seems to show the ocean is being heated by the moon's core. These hydrothermal vents could be similar as the ones found on the Earth's oceans and are hotspots for life. A team of scientists now want to send a probe to the moon to find out. It's called Orbilander, which would cost $2.5 billion. The probe would orbit Enceladus for 200 days, which won't be easy considering Saturn's giant gravity field. Orbilander will fly through these plumes of vapor, which will then funnel into science instruments at high speeds. But this probe won't only orbit the moon, it'll also land on the surface, and so it will need to find the perfect place. Once the location is found, the probe will convert to a lander. 2 nuclear power sources will keep Orbilander running on the surface of the moon for up to a year and a half while it sends data on what it finds back to Earth. If humanity wants to explore the universe, we'll have to learn how to colonize and terraform other worlds. But what exactly would it take to terraform a planet? And do we have the technology to make a planet like Mars comfortable for us? Discover what stands in our way of terraforming, which places in our solar system are the best for human colonies to be built, and find out how we just created oxygen for the first time on another planet. Planet Earth is the only place where humans can exist, for now. It's a scary thought that if our planet suddenly started to become uninhabitable, we'd have no place to go. Mars is one planet in our solar system that could be colonized. NASA wants to put humans there sometime in the 2030s. But when we send humans to Mars, they'll need a way to return to Earth safely, and those astronauts will also need oxygen to breathe. Mars is a cold and desolate world with a thin atmosphere that's made up of 96% carbon dioxide. NASA already has several rovers running around on the Martian surface checking it out, looking for signs of ancient life and seeing how habitable the planet might be. The Perseverance rover recently landed there, and it brought with it a very important experiment called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It's a small toaster-sized box that has 3 main components. On April 20th, 2021, MOXIE became the first instrument to create oxygen on another planet by separating oxygen atoms from carbon dioxide molecules while using high levels of heat for the conversion. During the first run of MOXIE, it produced about 5 grams of oxygen. That's about 10 minutes worth of breathable oxygen for an astronaut. But this small car battery-sized unit can only generate 10 grams an hour. But now that MOXIE has proven it can produce oxygen, NASA plans to build a much larger unit, about 100 times larger. Another big achievement of MOXIE is that it's the first kind of technology that just used elements of another world's environment and turned it into a usable resource. NASA calls it in situ resource utilization. Oxygen is also needed for rockets, and to get off Mars, a ship or rocket would need about 33 to 55 tons of fuel. That's where liquid oxygen comes in. Mars-made liquid oxygen could supply more than 3/4 of the fuel needed to explore the Red Planet, and could also fuel other missions to nearby planets and moons. And if you mix hydrogen and oxygen together, you either produce water or hydrogen peroxide.
Alright, there you have it mga ka-spacers. So I hope we were able to answer that question, what planets in our solar system aside from our planet Earth that are capable of supporting or sustaining life. And I hope mga ka-spacers, you have learned a lot about the possibility of life in some of the members or even moons in our solar system. So mga ka-spacers, please don't forget to like and share this video so that we could reach more people, especially the students out there, so that they will be inspired to love the sciences. And mga ka-spacers, don't forget also to subscribe to my YouTube channel, The Science Guy, Professor Jun Cajigal. So I guess that's about it for this video. So always stay safe. So thank you for your attention and for your time. This is your ka-spacer and Space Commander Professor Jun Cajigal saying live long and prosper. Thank you and so long for now.